Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll continue this topical MCQs on topic 3, which is on structure and bonding. So we're talking about crystal of iodine, which you know is a solid at room temperature and pressure. It's a grey black solid. As you will have known from your group 17 or group 7 chemistry from GCSE as well as O-level. And they produce a purple vapor when you gently hit them, because what they do is they skip through the liquid state. They can go to gas straight away. I talk about equilibrium, but in actuality, it's change of state, right? So you can go there and you can go back again. But solid to gas, that is a process called sublimation. So iodine is one of the few solids that can sublime to gas upon a little bit of heat. The other one being CO2, carbon dioxide. So they use carbon dioxide solid. Carbon dioxide solid is used in fire extinguisher. If you ever seen one of those solid powder fire extinguisher, they have solid carbon dioxide inside. And then when they press on, or they press on they squeeze on the nozzle thing, it will pass out carbon dioxide gas, because the solid sublimes straight away into gas, and carbon dioxide puts out your fire. It saves you from fire, okay? But these are simple molecular structure. So as I've shown you here, I've shown both of them as I and I and I and I, because you do not break the covalent bond, because these are simple molecular structure. And when we have compounds that have simple molecular structure, or in this case we have elements that have simple molecular structure, we only break the weak intermolecular force between the molecules. And here between these two intermolecular force, you can cross out D, because iodine, they are bonded to the same atom, they have the same electronegativity, they have the same attraction towards the bonding electrons, so they do not have dipoles one onto the other. They are just van der Waals forces. We are just talking about van der Waals forces because they are non-polar. Okay, because they have equal electronegativity. There is no unequal distribution of electrons at all, so they only have van der Waals forces. They do not have permanent dipoles. Therefore, we're just breaking the van der Waals forces, and we still have I2 in the gaseous state, being the purple vapor, whereas this is the grey black solid. So next question is a little bit of organic chemistry, but we can draw out CH3, CHO. You might not have done organic chemistry at this point, but that is beside the idea really. A lot of organic chemistry, the physical property come from structure and bonding anyway. So, it's not like you have to have done organic chemistry in order to work out structure and bonding, which is why you did structure and bonding before we move on to organic much later in the course. So which compound is the highest boiling point? What is the interaction that causes this boiling point to be the highest? Okay, so I've shown it here like this. As you can imagine, there is a delta minus and a delta plus because of the more electronegative oxygen. Same deal here, you have the delta minus, delta plus, and delta plus, delta plus, delta minus, delta plus. Okay, so in terms of van der Waals forces, all of them will have van der Waals because, well, all of them have electrons in their molecule, so they all have van der Waals forces. In terms of permanent dipoles, we are looking at, is the molecule polar or not? Okay, is the molecule polar or not? Well, you have a dipole there, so this is a polar molecule. Alcohol is also a polar molecule. You have a strong dipole due to the electronegative oxygen. The same deal here, you have electronegative oxygen. I've shown it as this way around, but in actuality, you know that the geometry is actually bent because, well, it's a oxygen with 2 bond pair and 2 lone pair. So you know your geometry is actually bent of 104 or 104.5 degree. So really, just like water, there is dipoles, and the dipole do not get cancelled out. So all of these are polar. So how do we decide then which one has the stronger intermolecular forces? We have to consider, can they form hydrogen bond or can they not form hydrogen bond? And a lot of students would think that, oh, this one, it has oxygen, it has hydrogen, it can form hydrogen bond. In reality, that is not the case, because the condition for hydrogen bond is you must have a hydrogen bonded to a fluorine or nitrogen or oxygen. Your hydrogen is not bonded to the oxygen, there is no hydrogen bond. Your your oxygen is bonded to carbon, your oxygen is not bonded to hydrogen at all. There is no hydrogen bond. This one has hydrogen bond because you have a hydrogen bonded to the oxygen. You also have the lone pair on the oxygen, so I could draw a second ethanol molecule. So I have a delta plus there. So from the lone pair, that's not very well drawn actually. So from the lone pair to the delta plus hydrogen, okay, so we show dipoles. We show the lone pair on the electronegative oxygen or fluorine or nitrogen, and then we show between themselves because this is a pure compound. We are talking about boiling point, so we are not talking about in water, we're talking about between themselves, and we're going to label that as hydrogen bonding. So these are typically worth 2 or 3 marks in a theory paper setting. So ethanol will have the highest boiling point due to the presence of hydrogen bond between the ethanol molecules. So in this next question, so this is about shape of molecules, so VSEPR, and then we talk about bond angle, which is to do with shape as well. Alright, so just because I've drawn it like this, it is not 180 degree. You have to consider valence shell electron pair repulsion, alright? So when you think about at here, so sulfur is below oxygen. So as you can imagine, water has got 2 bond pair and 2 lone pair, and there's 104 degree because there's 2 bond pair, 2 lone pair. When you talk about valence shell electron pair repulsion in theory paper, the lone pair repels. So that repels more than lone pair, bond pair, and that repels more than bond pair, bond pair. So this is a standard thing in a valence shell electron pair repulsion to explain the change in bond angle and the geometry, right? So the bond angle there for X is going to be 104, or you can talk about 104.5 degree because it's a band geometry with 2 bond pair and 2 lone pair. For Y, it's going to be 109 degree because there's a carbon bonded to 4 different atoms. So there is a carbon with 4 bond pair because there's 4 sigma bond, and 0 lone pair because the carbon has used all 4 outer shell electrons for bonding. So that is your standard tetrahedral, 109 degree, carbon sp3 hybridization. For your Z, that is around the nitrogen. It has got 3 sigma bond, so that's 3 bond pair, and 0 lone pair. That is your trigonal pyramidal. Just like in ammonia, you're going to have 107 degree. The more lone pairs, I have missed out something. Obviously, the more lone pair you have, the greater is the repulsion compared to this one with no lone pair repulsion. So this is the largest bond angle. So Y is the largest bond angle, and the smallest one is X, and the middle one is Z, leaving you C as the only correct answer. So in this question, so it's asking which molecule has the largest overall dipole. Overall dipole is the largest, means it's the most polar. So if it is the most polar, it means dipoles do not cancel out. Because if dipoles cancel out, then you get a symmetrical distribution of charge, then you will get non-polar molecule. Be very careful, yeah? Polar bond does not mean polar molecule, alright? So here, this is polar bond. Each of these bond is polar, but because this is oxygen-oxygen, so this magnitude is the same as this magnitude. So dipole is a vector quantity. It has value, meaning it has magnitude, and it also has direction. So because they are acting in opposite direction in equal magnitude, so this molecule is non-polar. Okay, so D is not the correct one because D is non-polar. A is also non-polar, despite having this electronegative chlorine and despite having dipole and despite having polar bond. This is 180 degree to each other. They are on different carbon, but they are aligned in such a way that these cancel this one out, just like these cancel this one out because they have the same magnitude, because they are the same CCl bond in opposite direction. Okay, when I have the other one, these also cancel this one out, so this molecule is actually non-polar. Between B and C, to find out which one has the largest overall dipole, we need to consider this one is acting that way, but then because you have a different atom, this is acting this way and this is acting this way. So going this way, going to the right, is going to cancel going to the left. Whereas if I consider C and H, this is actually going this way. This is actually going this way as well. Okay, but they are very small because they are not very different electronegativity, unlike carbon and chlorine. So what is next is you have that carbon oxygen which is going that way. So overall your net dipole going that way. Whereas here, you have a cancellation of this dipole by this dipole acting in the opposite direction. So we'll be considering that B has the largest overall dipole. This is the last question of this 5-question series. Again, it's asking you on the correct order of the bond angles shown there. You want to show the smallest angle first. To do with bond angle, you have to work out the geometry about each and every one of these. Alright, so if I work out number 1, the carbon there has 4 sigma bond. So 1, 2, 3, 4. Carbon is in group 14. Uses O for bonding, so that's just 0 lone pair. That is tetrahedral. That is 109 degree. Do not put it down as 90 degree just because they show it like that, because that is their job to try and confuse you. Same deal with number 2. So you don't count. So that is 1 sigma plus 1 pi. You only count the sigma bond for your bond pair in your VSEPR. So that is 1, 2, and 3 sigma bond. So there's 3 bond pair. And there's 0 lone pair because altogether the carbon has used 1, 2, 3, 4 because it has formed 4 covalent bond. There's 0 lone pair. That is your trigonal planar, 120 degree. Okay, not 90 degree as they have shown there, because it's always shown like that to try and confuse you. And this is definitely not 180 degree. You need to consider that oxygen is in group 16. Oxygen is in group 16, in case you don't know it. 6 outermost shell electrons. Just because they don't show you does not mean that it's not true. You're given periodic table. You also have learned oxygen is in group 16 since, I don't know, when you first given periodic table. So that would mean that the oxygen has 2 sigma bond, 1 and 2, and you still have 2 lone pair, just like in water. In water, which is your case study, the oxygen is in group 16, forms 2 sigma bond, and it has 4 outer shell electrons left because it only used 2 for bonding. So altogether you get band and 104 degree because the lone pair repel more than bond pair lone pair, repel more than bond pair. So starting from the smallest angle, this is the smallest. So number 3 is the smallest, number 2 is the biggest. Number 3 is the smallest, number 2 is the biggest, so C is our answer. So this marks the end of this 5-question series on topical MCQs on structure and bonding, one of the most important topic of all in the whole of A-level chemistry, because they relate to all your chemical structure and reactivity, they react to your physical properties, etc., etc. If you find these videos and the rest of the other playlists on my channel useful, do subscribe to the channel, share them widely with friends, your class group chat, your social network, probably far more extensive than mine. And thank you for that, thank you for sharing, and thank you for watching. I'll see you in the next video.